So for our last lesson for this unit, we're going to be talking about fractions involving radicals. I've given you an example, and then we're going to try 3 examples of our own. If you take a look at the example, we have 1 over root 12 minus 1 over root 27. And my first instinct, as soon as I see any radical, is to try and simplify it as much as possible. So I know root 12 can be simplified to root 4 times root 3. And I know root 27 can be simplified. So this can be root 4 times root 3, and this can be root 9 times root 3. So in the next step, we did that, but we simplified it. So root 4 became 2 root 3, and root 9 became 3 root 3. That is basically what you end up with. Now, in any sort of fraction, when you're adding or subtracting, you have to make sure that your denominators are the same. But before that, we have to get rid of the radical because that's poor form. So we're going to rationalize the denominator separately. Each fraction is separate, so you may have to rationalize it in different ways. In this question, both of them have a rational of root 3. Sorry, a radical of root 3. So we rationalize it using root 3 over 3 here and root 3 over here, 3 here. Once you ended up with a step that doesn't have any radicals in the denominator, then you can find a common denominator just like you do in regular old fractions, and then solve. Okay, so that's basically our game plan for the next 3 questions. Let's try question number 1. For question number 1, again, first we're going to simplify root 54. What are 2 numbers that multiply to give us 54? So root 9 times root 6 minus, and then 32. The best option would be root 16 times root 2. Okay, now we're going to, if you wanted, you can actually just do all of that in one step, but I'm going to rewrite it. So it's 3 root 6 minus 1 over 4 root 2. At this stage, we can go ahead and rationalize the denominator. So for the first fraction, I'm going to multiply the numerator and denominator by root 6. And I guess I don't have enough room, so I'm just going to move this over until later. And I do want to see all your work for this, just because if you mess up on a certain step, it helps me give you part marks at least if I can see all of your work. Okay, so when we rationalize the denominator, hopefully you guys did your homework from yesterday. The numerator in the first fraction is going to become root 6. I'll show all my work, but you don't actually have to write this next part. I know root 6 times root 6 is a whole number 6, so that's really going to be 3 times 6. And if you wanted, you could just write 18 right away. For the second fraction, 1 times root 2 is root 2. And then again, we have a 4, and then root 2 times root 2 is just going to become whole number 2. Now, just so I can save some steps, I'm going to erase this and change it to an 18. You can just rewrite it again, and I'm going to change this to an 8. Okay, we're ready. We can't simplify it any further, but we're in a really good situation right now because we don't have any radicals in the denominator. Everything has been moved up. So now we just have to find a common denominator. What do you think a common denominator in this case is? Okay, so I'm gonna multiply this by 4 and this by 4. We established that it was 72, this by 9 and this by 9. So my numerator here is going to be 4 root 6. My numerator here is going to be 9 root 2. And I'm just going to write the entire denominator as 72. You guys, in our very final step, I kind of briefly went over this last class, but we'll do it a little bit more today. You look at all of the coefficients and you ask yourselves, are these coefficients factors of each other or multiples of each other. And if they are, then you would actually have to simplify them. But 4, 9, and 72, are they all factors or multiples? They're not. And so our final answer would just be 4 root 6 minus 9 root 2 over 72. Okay, question number 2. Again, we're going to look at each fraction separately, and we're going to try to simplify it as much as we can. So for this question, I have 2 root 3 over. Now, 18 can be simplified to 9 times 2 or 6 times 3. We could do either or. If in the end we'll get the same answer. Let's go ahead and do 9 times 2. And then for the second fraction, we have root 3, and then 20 can be simplified to root 4 times root 5.
Is the last step optional?
The last step in the previous question?
Yeah, like you know how you multiplied the first fraction by 4 and then the second by 9? Is that?
No, that's not. You have to do that. Yes, you have to do that. Okay, as the question was, do you have to find a common denominator in the question? And the answer is yes, you do. Okay, so we're going to just keep going. Our root 9 is going to become a whole number 3. And then the second fraction will be root 3 over 2 root 5. Okay, now we're going to rationalize. We can't simplify any further. Nothing's really crossing out. This is the most we can do. So we're going to rationalize each fraction. This is going to be multiplied by root 2 and root 2. This is going to be multiplied by root 5 and root 5. Okay, so now when we keep going, the numerator in this case is going to be root 3 times root 2 is root 6. So it's going to be 2 times root 6. And this time, maybe we won't show all of our work. I know root 2 times root 2 is a whole number 2, and 3 times 2 is going to give me a 6. Okay, the second fraction, root 3 times root 5 is root 15. And again, root 5 times root 5 is a whole number 5. 2 times 5 is just going to give us a 10. Can we simplify any of these fractions before we find a common denominator? Yeah, we can. The 2 and the 6, right? We can actually simplify the 2 and the 6 to give us a 1 and a 3. All right. Contemplating if I should just write that again so that.
Do you leave the number that's in the square root alone? You don't simplify it, right?
Exactly. Okay, and our common denominator would be 30. So we're going to multiply this by 10 and this by 10, this by 3 and this by 3. And then we basically get 10 root 6 plus 3 root 15 all over the number 30. When you get to the end, how do you know that's the final answer? Like the numbers seem pretty big. So again, we're going to look at our coefficients, 10 and 3 and 30. Are they common at all? Are there any common factors there? No. So we know the coefficients is as simplified as we can get. But you should also just take a look at the radicals and make sure that you can't simplify it any further. Because if you ended up with a radical that was like, 18 or something, and you could take out a root 9, it's not as simplified as possible. So you want to make sure your radicals are also as simplified as possible in order to make sure the question is correct. Okay, last example, and then you guys can try some of these questions yourselves. Let's go ahead and do question C. I know some of you are already working ahead, which is fine. I'll just keep going as well. So I have -5 root 2. And 24, I can simplify to give me 6 times 4. So root 4 times root 6 minus 2 root 3. And 8 can be simplified to give me root 4 times root 2. I'm going to just keep going and simplify that some more. If you are comfortable, you could go right from root 24 to 2 root 6. Like you could kind of skip that first step. Okay, so just looking at each one of my fractions, is there anything I can simplify within each fraction? I can actually do a couple of things. Anyone see anything? Yeah.
So where's the one that's 2?
Yep. Yes, I can definitely cancel out the 2's. There's actually something else I can do as well. Anyone see it? Kevin? Yeah, so see how I wrote down root 6. What I could have done is I could have actually simplified it to give me root 3 times root 2, because then I actually have a matching pair of numbers and I can reduce those. Okay, so in the second fraction, I simplified 2 over 2. However, in the first fraction, I could have actually simplified root 6 a little bit more, which I did end up doing when I identified that I could do that. So when all of that is done, we're left with -5 over 2 root 3 minus root 3 over root 2. All right, we're not allowed to have any radicals in the denominator, so I'm going to rationalize the denominator by multiplying this one by root 3 and this one by root 2. So the first fraction is going to become -5 root 3 over 2 times just 3, which is 6, minus root 3 times root 2, which is root 6, over the number 2. This one's really easy. All we have to do is multiply the second fraction by 3. And we end up getting -5 root 3 minus 3 root 6 all over 6. I was really hoping one of these examples would have one of those examples where you can factor out a coefficient. I'm sure when you guys start the worksheet, there will be a couple of examples of that. And then maybe we can take some of them up.
Is it right if you go up a little?
Yeah, of course. Bless you. So while you guys are finishing off the question, your home or classwork, because we have so much time, is going to be just the back page. And also, I have put a couple of review questions from the textbook on that page as well, if you take a look at the bottom right-hand side. But before you guys start working, I do want to take up some questions from your assignment. So let's do that, and then you can work. For you guys at home, I'm just going to scroll down so you can see the practice questions. Just take a screenshot of those. And just take a look at the bottom right-hand side. There are review questions from the textbook as well. Goodbye, recording.